Hey, hi everyone. Welcome to our project presentation. Uh, we are diving into sentiment analysis using IMDb movies reviews implemented in entirely in KNIME. The objective here is to classify reviews as either positive or negative and analyze pattern in how people express emotion about movies. This kind of analysis helps business like streaming platform, media agency, or production houses understand the audience feedback at scale level. Methodology, what we have used in the KNN. So let's look at the Knime workflow here. Uh, we start by reading the IMDb dataset using the CSV reader. Then we reprocess the text by removing punctuation, lower casing, filtering, stop words, and stemming. So this clean text is converted into document format and fed into a bag of words model. We vectorize these reviews so that machine learning model can interpret the sentiment inside. Next, we able to sentiment is positive or negative. Split the data using the table partitioner and train two classifier. One is decision tree, another is XGBoost. These model predicts sentiment based on the review structure and vocabulary. Anyway, I'll walk through the K9 nodes, which is one is file reader, then pre-processing, then feature extraction, then model learning. Okay, then we have seen everything in the ROC core, and also we have true false kind of confusion metrics are there, false positive and false negative and all that I'll explain later. How did we start it? Let me go to the starting part, like what exactly sentiment analysis is and how did we gather the data from Kaggle. We took the movie review data set and all that I will explain. One by one. So sentiment analysis of free text document is a common task in the field of text mining. In sentiment analysis, predefined sentiment labels such as positive or negative are assigned to text. Text is something nothing but our documents. Okay. So in this flow, we'll show you how to assign predefined sentiments label to documents using text processing. Okay, and Knime is open source. Basically, you can download it from the internet, and also there are a lot of datasets available in Kaggle. You can download it, and but here we have taken the movie review dataset. So basically, here we have taken around two. 1,000 documents for this pre-processing, though the original file contained around 50,000 movie reviews along with their associated sentiment level positive and negative. We sampled 1,000 documents for the positive and group by, and another 1,000 documents of the negative group for this goal. So here is to assign the correct sentiment level. What we did, um, uh, first uh, first we have started with the CSV reader. So basically what CSV reader will do, this workflow start with the CSV reader node reading the CSV file that contains the reviews text it associated sentiments label for this IMDb, and it's indexed in the large movie review dataset. Important are the text and sentiment column. In the fast metanode document creation, document cells are created from the string cell using the string to document node. The sentiments label are stored in the category field of each document to remain available for later tasks, and all the columns except the document column are filtered out. The output of this fast metanode document creation is data table with only one column containing the document cells. Later we'll go to the next node, that is our pre-process the text. So in this node, the textual data is pre-processed by various nodes provided by the Knime text processing extension. All pre-processing steps are applied in the second meta node, pre-processing as on in our figure. Uh, First punctuation marks are removed by the punctuation eraser node. Then the numbers and stop words are filtered and all terms are converted to lowercase. After that, the stem is extracted from each words using the snowball stemmer node. Indeed, the words selection, selecting, and to select refer to the same lexical concept and carry the same information in a document classification or topic detection context. Beside English text, the snowball steamer node can be applied on text of various languages like German, French, Italian, Spanish, etc. The node is using snowball stemming library. So basically, this is a library. Excuse me. Extract features and create document vector. After all the pre-processing, we reach the central point of this analysis, which is to extract the terms to use as component of the document vector and as input feature to the classification model. To create the document vector for the text, first we create their bag of words using bag of words creator node. Then we feed the data tables containing the bags of words into document vector node. Then the document vector node will take into account all terms contains in the bag of words to create the corresponding document vector. Notice that uh, text is made of words and document, right? Which is text including some additional information such as category, authors, or contain something other words, or including some additional information such as grammar, gender, or stem. Okay, so since texts are quite long, the corresponding bags of words contain many words. That the corresponding document vector can have a very high dimensionality, too many components. I mean, and the classification algorithm can suffer in terms of speed performance. However, note all the words in the text document are equally important. Okay, a common practice is to filter out all the least informative words and keep only the most significant ones. And good measures of the word importance can be indicated by the number of occurrence of words in each single document as well as in the whole dataset. Based on this consideration, after the bag of words has been created, we filter out all terms that occurs in less than 20 documents inside the dataset within a group by node. Um, we group by terms and counts all unique documents containing a terms at least one. The output is a list of terms with a number of documents in which they occur. We filter this list of terms to keep only those terms with the number of documents greater than 20. And then we filter the terms each base of word accordingly with the reference row filter node. In this way, we reduce the feature space from 20,379 distinct words to only 1499. This features extract process is part of the preprocessing meta node, and you can see this figure in our flow, right? So we set the minimum number of document to 20 since we assume that the term size occurs at least 1% of all the documents, 20 of 2000 in order to represent a useful feature for classification. This is a rule of thumb, and of course can be optimized. Definitely there is no issue with that. Document vector are now created based on these extracted words features. Document vectors are numerical representation of the document. Here each word in the dictionary becomes a component of the vector, and for each document assumes a numerical value that can be 0 or 1. So I mean 0 for the absence and 1 for the presence of the word in the document, or a measure of the word importance within the document, example word scores or the frequency. The document vector node allow for the creation of bit vector 0 or 1, or you can say it's a numerical vector. A numerical value previously calculated word scores or frequency can be used by the TF or IDF nodes in our yes, we have it is used positive and negative. Use supervised mining algorithm for classification. For classification, we can use any of the traditional supervised mining algorithm available in Knime analytic platform like decision tree, random forest, support vector, machine, neural network, and much more are there. But here we have chosen only decision tree and random forest. As in all supervised mining algorithm, we need to target variable. In our example, the target is the sentiment label stored in the document category. Therefore, the target or class column is extracted from the document and appended as a string column using the category to class node. Based on the category, a color is assigned to each document by color manager. Is obviously there is a node. Document with label positive are colored green, and document with label negative are colored as red. That I'll show you. Well, I'll go to the flow by each node. A classification algorithm we use to we use a decision tree and a XGBoost tree, as I already said, enabled, applied on a training. 70% of data we have used for training purpose, and 30% data we have used for test purpose, randomly extracted from the original data set. The accuracy of the decision tree is around 91.3, and the accuracy of the XGBoost is around 92.0. The corresponding ROC curves are presented also in the figure. I'll show you that. Uh, um, while performing slightly better, XGBoost tree example does not have the interpretability that the decision tree can provide. Basically, our figure shows a view of the first two levels of the decision tree, the most discriminative terms with respect to separation of the two classes are bad or waste, and films, or the worst films. If the terms bad occurs in a document, it is likely to have a negative sentiment. If bad does not occur, but something kind of waste, something occur, it is again like to be negative document, and so on. So we'll quickly go to the our flow. This is my CSV reader. As I said, this will read my file, CSV file, and as I said, these are my document creation. This is my pre-processing. This is my document vector. This is my category to class. This is my color manager. As I already said, we have two class, two color. One is negative, one is positive. Basically this will give the colors, and this is my table partitioner, as you can see. So if I'll click here, you will able to see we are partitioning the table into two parts. One is for training purpose, one is for test purpose. Okay, if you click on this node, you can see here that around 1400 record, if you can see here, 1400 record is going for the uh, training purpose. Okay, and around 150 is our columns numbers, and you can see here 600 rows are going to for test purpose. Okay, and same 1501 is the column count, or number of columns available in that file. So this is my decision tree, this is going here, this is my trainer, this is my trainer, this is my tester. Basically this will take the test data, and this will give the scores. Okay, this will give my, this will give the confusion matrix. So you can see here first post is 277. As I said, right, we have total the total number of records is moving to the test part is around 600. So if you see here, the positive 277, positive to negative 23, negative to positive 29, negative to negative 271. This is for my um decision tree. And the accuracy is, if you can see here, accuracy is 91.33, and correct class classified is 548, and wrong classified is around 52. Similarly, we'll go to the XGBoost here. I can show you the total score here. This confusion matrix, post to post, positive is 288, positive to negative 12, and negative to positive is 36, negative around 264. Here correctly classified are 552, and wrongly classified are 48. You can see here the accuracy is slightly better, it is 92%. Okay, now this is some column filter I applied for that. I need the numerical things to do the ROC curve. If you'll go here, mm, you will get the ROC curve here, right? The red one, the orange one, basically, and the blue one, and this is our random line. So if you can see here, the orange is little better compared to our decision tree. Okay, slightly upper compared to our decision tree, which is the blue line. So this is my ROC core, and you can see here we have two axes, y axis and y axis. Y axis is basically true positive rate, and x axis is basically tells you about the false positive rate. Okay, so basically this is my workflow of my model. So now we'll go to the conclusion part, what exactly we concluded here from this workflow. uh, uh, the conclusion will be, in summary, our Knime workflow effectively classified IMDb reviews with high accuracy and meaningful insight. XGBoost proved most effective, and visualization help us to understand how sentiment correlates with range, rating score, and others word choices. This type of sentiment analysis can help platform moderate reviews, personalize recommendation, and even assist in market research. Thank you for watching. If you have any feedback, feel free to comment or reach out uh, to our team. Hope this demonstration shows how Knime can be used for impactful and scalable NLP projects.